Okay, so my last part in this three-part series, I guess it's kind of like Lord of the Rings, Return of the King. I mean, it's a great series, and the unit circle, as I mentioned in the first video and the second video, and now the third, this should be one of your top three circles. Uh, this is going to really bring everything together using the angles. We are not going to get into using trig functions with the angles. That will be taught in a separate trig class, but this will help you understand where the coordinates come from and how we can derive the coordinates if you forget what they are. Really, it's just going to be a great time, and even if you didn't watch the first two videos, just like Return of the King, Lord of the Rings, this is still going to hold up on its own too. So we do need to recall some stuff from geometry, and that is our 30, 60, 90 triangle and our 45, 45, 90 triangle. Um, so we need to remember the relationships because if we recall from the degrees of the unit circle, the 30, the 60, and the 45 are really the main degree angles that we're dealing with. So opposite 30, we call this A. I'm intentionally not using X because we're talking about coordinates and there is an X coordinate and that can sometimes be confusing, but this can be whatever variable you want. So this is A, the hypotenuse is 2A, opposite the 60 is A root 3. In the 45, 45, 90 triangle, opposite the 45s are A, and then the hypotenuse is A root 2. Great. So here, just like with everything else, if we focus on the first quadrant, everything else will make sense. This is, I mean, in everything that's true, but whenever your math teacher tells you how math builds upon itself, this is one of those perfect examples where if we understand symmetry, if we understand reflections, if we understand just coordinates in general, if we understand distances, all of those can help us understand how to work the rest of the quadrants. So let's focus on the first quadrant here. And I'm going to start with the 30-degree angle. So I'm going to redraw that triangle. So this is my, remember this here is the 30 degrees, this is the 60 degrees. But if this is the unit circle, what do we know the hypotenuse is? Well, the hypotenuse represents the radius of the circle. What is the radius of the unit circle? That's 1. But remember, this side here is going to be half of that. And I know that because if I look at my 30, 60, 90 triangle, if this is 2A, then this is A, right? So what is 1 over 2? That's 1/2. If that's 1/2, then this side is going to be that number times root 3. So what is 1/2 times root 3? Well, it's 1/2 root 3, or sometimes we'll write it as root 3 over 2. That's usually how we see it on the unit circle. So this coordinate here, if I think of it as an xy point, well, this is the distance in the x direction. So I'm going to write that as root 3 over 2. And then this is the distance in the y direction. So that's 1/2. So at my 30 degrees, the coordinate is root 3 over 2, comma 1/2. Now let's look at the 45 degrees. So if we draw in that 45, 45, 90 triangle, remember this is 45, 45, but again, the hypotenuse of the triangle here is the radius of the circle that represents 1. On our 45, 45, 90 triangle, remember the hypotenuse was what we called A root 2. So if I know 1 equals A root 2, what does A equal? Because each side of the triangle equaled A, well then it'd be 1 over root 2 equals A. A lot of times we will see this rationalized, so that's root 2 over 2 equals A. So therefore this side here, root 2 over 2, this side here is also root 2 over 2, and then I know that my coordinate is root 2 over 2, comma, root 2 over 2. Now the 60 degrees, is going to be the same exact thing as the 30 degrees, but we're going to switch the coordinates. Because again, if we draw this triangle, I know now that this is 60 and that this is 30. This is still 1, so opposite the 30 is half of that, and this side is going to be root 3 over 2, or 1/2 times root 3. So my coordinates now are 1/2, comma, root 3 over 2. Now, when we put this all together, we also need to take into account that at 0, remember it's a radius of 1, so this is 1, comma 0. At 90, it's still a radius of 1, but this is going to be 0, comma 1. And then we had 3 over 2, comma 1/2. Root 2 over 2, root 2 over 2. And this was 1/2, comma root 3 over 2. Now, what I was talking about at the beginning, this is where we have 0 work to do to fill out the rest of the unit circle as long as we know these coordinates. Because all I have to do is change positives and negatives. Because I know if I was to draw triangles, it would be the same exact triangle, but now the negative gives me a direction. And so if I'm in the second quadrant, I know that all of the x coordinates are negative. This is going to be -1, 0. And this is going to be the same as the 30 degrees, except for it's going to be negative root 3 over 2, comma 1/2. This will be the same as the 45 degrees. It'll be negative root 2 over 2, comma root 2 over 2. And this will be the same as the 60 degrees, except for it'll be negative 1/2, comma root 3 over 2. Because again, if we think about when we created the degrees and the radians as well, we kept drawing the same, what I refer to as reference angle. And that was that this angle here, in this case, is also 60 degrees. Draw a triangle. And so I have a 30, 60, 90 triangle, and I can label my sides. Now we can see this completely filled out on a unit circle with degrees, radians, and the coordinates. Again, this just helps us see that pattern in the coordinates. Notice that here, this is our 30-degree reference angle. It has the same exact coordinate, but now that we are in the third quadrant, both the x and the y values are negative. So x and y are negative in the third quadrant, and then in the fourth quadrant, the x values are positive, but the y values are negative. But they still correspond to 30 degrees, or pi 6. I have root 3 over 2, comma 1/2. So at 330 degrees, or 11 pi over 6, I have root 3 over 2, comma negative 1/2. And those are the coordinates on a unit circle. Again, the big thing is recognizing the pattern, and once we get these down from our 30, 60, 90 triangle and our 45, 45, 90 triangle, we don't need to rememorize all of these other coordinates. They are not different coordinates. They're the same exact coordinate, just with a different positive or negative. So you just need to understand your coordinate axis and know where are x and y positive or negative. One last pattern I want to show you because again, it is the unit circle. There's a lot of patterns. Patterns are fun. All right, so again, what I'm going to show you is a little pattern that if you really forget things, if you forget your 30, 60, 90 triangle or your 45, 45, 90 triangle, this is a pattern that you could possibly remember. It's also just, fun to point out because patterns are cool. So what we're looking at here, I've made this little chart. This is the angle, and I intentionally am going up just because that's how we go around the unit circle. So 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and this is the y value or the y coordinate. So the y coordinate at 0 degrees is 0, 30 degrees is 1/2, 45 is root 2 over 2, 60 is root 3 over 2, and 90 is 1. Maybe you're looking at that and you're like, okay, great, I don't see the pattern. Well, here's the pattern. So I can think of 0 as root 0 over 2, because the square root of 0 is 0. 0 divided by 2 is 0. I can think of 1/2 as root 1 over 2, because the square root of 1 is 1, so it's 1 over 2. This is root 2 over 2, this is root 3 over 2, and this is root 4 over 2, because what's root 4? Root 4 is 2. Excellent. 2 divided by 2 is 1. Very good. You're catching on. So now we can see there is a pattern. It's kind of cool. Similar to some of the patterns that I showed you with the radians, if you watch that video, it just becomes counting and knowing where, once you know where to start counting, then you just count by ones, and hopefully we can do that if we're dealing with the unit circle at this point. Also, if we understand this pattern, then the x coordinates are the exact opposite, or the same thing, but in the exact opposite direction. So just another fun way to help you remember the coordinates on the unit circle.